Example 5. Solve the triangle. Round to 2 places after the decimal point if necessary. So here, side length B is 4 units. The length of side C is 3 units. And angle B measures 40 degrees. All right, let's first draw the triangle. Okay, I am going to put in my horizontal first. Oops. So let me go ahead and do that. So here's my horizontal right here. Okay, it doesn't have to be a perfect triangle. Okay, we are told one of the angles here, it is a 40-degree angle, so just kind of estimate that. Okay, so maybe 40 degrees is about, I don't know, there. Okay, so we'll go ahead and say this is the 40-degree angle. This is angle B. Okay, I'll go ahead and put in the third side to the triangle. Okay, so we know if we go straight across from angle B, this is going to be side length B. We are told that is 4 units long. Okay, we have information about side length C, so just pick a side. Let's say this is C. Okay, so C is 3. If we go across from that side, that means this angle should be C. Okay, the remaining angle needs to be A, and then the side across from A, okay, is going to be side A. Okay. All right, so here we go. This is what our triangle looks like. Okay, so let's go ahead and identify the case. Okay, so remember the case is based off of the information that has been given to us. Okay, when you look at this, you have a side, and then an angle. Okay, so this is going to be side, angle, the ambiguous case. Okay, so we know with side, angle, there can be 0 triangles. We saw that in example 3. There can be 2 triangles. We just saw that in example 4. And there can be exactly 1 triangle, and you will see that case in this particular example. Okay. Anytime there's side, angle, you're going to want to use the law of sines here. Okay, so let's get started. We need to find side A's length. We need to find the measure of angle C and the measure of angle A. Okay, we need to figure out where to begin. Which of the 3 quantities that we are looking for, which one is going to be the easiest to find? Okay, we need to go ahead and set up a ratio. Okay, we're going to use B information in our ratio because we have both the angle measure of angle B and we have side length B. So our ratio is going to contain the sine of B over B is equal to the sine of one of the other 2 angles over the corresponding side length. Should we use A or C to start with? Well, the answer is C because we have half the information about C. We know the side length C is 3 units. Okay, so we're going to do sine of C over C. Again, if you had used A, sine of A over A, you don't know angle A and you don't know side length A. So that would have, you'd have more than one unknown in your statement, and so then you can't solve. Okay. All right, so if we plug into this, this is going to tell us that the sine of 40 degrees over 4 is equal to the sine of angle C, which we don't know angle C. That's got to be over side length C. That's 3 units. Okay, we've got one unknown here. That's angle C. We've got to cross multiply. That is going to tell us that 4 times the sine of C is equal to 3 times the sine of 40 degrees. Okay, and so then we're going to go ahead and divide both sides by 4. Okay, that's going to tell us that the sine of C is this particular quantity. Okay, 3 times the sine of 40 degrees over 4. Okay, I am going to go ahead and punch that into the calculator. Okay, so let's see here. I'm going to do, this is going to be 3 times the sine of 40 degrees over 4. Okay, this quantity is not the angle measure. This is the sine of angle C. Okay, so I'm going to go ahead and write that whole decimal down. So this is going to be 0.482090773. Okay. All right, so keep that in mind because this is the ambiguous case. You're going to have to return to this statement, okay, to figure out if there's a second triangle. Okay, so let me start that. Okay, let's go on and continue to get the measure of angle C here. C is trapped by the sine. Okay, so we're going to go ahead and take the sine inverse of both sides. Okay, so let's do that. Okay, so we're going to get that the sine inverse of the sine of C, okay, is equal to the sine inverse of this decimal 0.48 blah blah blah. Okay, on the left side, the sine inverse and the sine will cancel. It's going to leave us with angle C's measure. Okay, we're going to go to the calculator and we're going to type in the sine inverse of this decimal. Okay, so you can just do second negative sign or second answer, however you want to look at it, or you can just punch in the decimal. You need to carry all the digits for accuracy. Okay, so angle C is going to measure this quantity. It's going to be in degrees. Make sure your calculator is in degrees. Otherwise, the angle that's returned will be in radians. Okay. All right. So let me go ahead and write this down. This is going to be 28.22, or sorry, 822.03 865. All right, so that is in degrees. So if we go ahead and round this to two places after the decimal point, angle C is going to measure 28.82 degrees. Okay, so I'm going to go over here and put it in the triangle. Okay, this is approximately 28.82 degrees. Okay. All right, so let's talk. Okay, at this point in the game, when you're dealing with the ambiguous case, you want to take some time before completing the triangle. You want to figure out if there is a second triangle. Okay, so remember what this means. Okay, we're going back to this statement when we were solving for angle C. The sine of angle C is this quantity about 0.48. Okay, so remember what that means. Okay, if you were to look at the unit circle, and so I'm just going to draw a circle, and here this is going to be our unit circle that we're looking at. Okay, so we found angle C to be an angle about 28.82 degrees, so almost 30 degrees. So if you were to put this angle C on here, okay, so like this, okay, I'm just estimating here, I'm just eyeballing, okay. So say this were, angle C at this point, okay, so angle C, this is about 28.82 degrees, okay. This point, corresponding point on the unit circle, we don't know the x coordinate, but we know the sine value, which is the y coordinate. It's about 0.48. Okay, it's this number right here, that 0.48209 number. Okay, so the way you have to think about this, okay, remember in quadrants 1 and 2, the sine values are positive, so there's gonna be some angle in quadrant 2 that has the same sine value, that has the same y coordinate. Okay, so if you drew that out, okay, you're looking for some other point on the unit circle that has the same height. Okay, so if I did it like this, if I drew this, okay, see how these two dots, the red dot and the blue dot, have the same height? That means that their y value is the same. Okay, so this angle, okay, which I'm drawing the red angle here, it's going to have the same sine value. Okay, so this red angle is a potential second C angle. Okay, if there is a second triangle, okay, this would be angle C in that triangle. Okay, so again, let me notate here, we don't know the x coordinate of this this red dot, but the y coordinate should also be a 0.48209 dot dot dot. Okay, all right, so we've got to figure out the measure of this angle. Okay, so if you remember when we did this back in example, the last example, what example? That was example 4. Okay, we made right triangles out of these guys. Okay, so we made right triangles and we said that these triangles were congruent. Okay, and so therefore we said the blue angle is equal to the angle right here. They have the same measure. So if you take the red angle, which is the potential second angle C, and you add it to the blue angle, they should equal a straight angle, which is 180 degrees. Okay, so what you're seeing here, this angle C2, the potential second C angle, okay, it's going to be equal to 180 degrees minus the blue angle, okay, which is 28 point, let's see, 28.82203.865. Okay, so that is what the potential second angle would be, okay, for C. Okay, so if you plug this into the calculator, you can do 180 minus that result. Okay, so the other angle C would be about 151.18. Okay, now just because we have a second C angle here doesn't mean there necessarily is one. Okay, so remember, if this is your potential angle, okay, for angle C, you know angle B has to be 40 degrees. You can't change that given information, okay? And then there's still going to have to be room in your triangle for angle A, okay? So if you were to add these two guys up, angle B and angle C, okay, when you tack on the 40, it already surpasses 180 degrees. So there's not room, okay, for a third angle. You don't even have room for both of these angles to be in your triangle. You've already exceeded 180 degrees, okay? So if you do B plus C2 here, okay, this exceeds 180 degrees, okay? So we can conclude there is no second triangle. Okay, there is no second triangle. Okay, you always have to check for one in the ambiguous case. Okay, the easiest thing that's going to happen to you in the ambiguous case, which is always side angle, which is always law of sines, the easiest possible thing that can happen is that there is no triangle. Okay, you will be computing as normal, and then you'll pop it into your calculator to solve for the angle, and you'll get an error message. Okay, that's going to be the easiest case. It is two triangles in one triangle you're really going to have to think hard about. Okay, all right, so we are only going to get one triangle out of this situation. Okay, so we need to concentrate on solving it. Okay, so we have out of the angles, we have angle B taken care of, we have angle C taken care of. We need to get angle A, and we also need to get side length A, and then we will be done. Okay, I am going to take a minute. I'm going to go fill in what I already know, okay, because I haven't kept up with this. But let's see here. We know that angle B is 40 degrees. Let's see. Oops. Angle B is 40 degrees. And we know side length B is 4. Okay, let's see, what else do we know? We know that angle C is approximately 28.82 degrees. And we know that, let's see, side length C is 3. Okay, so that tells us we've got almost everything except for A and A. Okay, all right, so here we go. Let's figure this out. So what do we do next? Okay, you might think, okay, well, since I need the A stuff, let me go ahead and set up a ratio. Sine of A over A is equal to, you know, either sine of B over B or sine of C over C. Okay, the problem with proceeding this way is that you don't know angle A and you don't know side length A. Okay, so if you plugged into this, you're going to have two unknowns and you're not going to be able to solve. Okay, what you need to do here, okay, you need to realize that you now know two of the three angles. Okay, so all you need to do is subtract both angles from 180, and that's going to give you angle A. Okay, at this point, let's see here. Let's do this. Okay, so for the measure of angle A, so let's see, I'll put angle A here. Okay, we've got to compute that. Okay, we need to take 180 degrees, subtract out angle B. Okay, so that's 40 degrees. And then we need to subtract out the measure of angle C. Okay, and I'm going to go ahead and use all the decimals. Okay, so let's see, this is going to be 28.82203.865 degrees. Okay, reason being is because I'm going to have to come back next and I'm going to have to compute side A. Okay, I need all the digits for accuracy. Okay, all right, so if we compute this, for angle A. Okay, and this is just an easy subtraction here. Okay, let me fit this in the screen here for you. Okay, so let's do it. Okay, we're going to get that 180 minus 40 minus this 28 and change number. Okay, so here is angle A. Okay, so A is 111 degrees, and I'll write this down, 17796. 1779614. Okay. All right, so if we go ahead and round that to write down the answer, angle A is going to be about 111 degrees, 111 point, let's round to two places after, so 0.18. Okay, so that's going to be the measure of angle A. Okay, we're approximating that. Okay, again, angles A, B, and C need to add to be 180 degrees. Okay, we can go ahead and label it in our picture if you want. Okay, so we only need one more component of the triangle and we are done. Okay, cannot emphasize enough, this is an oblique triangle. You cannot use the Pythagorean theorem. Do not do c squared is equal to a squared plus b squared. Only works if you have a right triangle. Okay, I mean, just think about it. If you were trying to plug in for that, which side's going to be the hypotenuse? Okay, there is no hypotenuse here. Okay, all right, so to get side length A, okay, we are just going to use the law of sines. Okay, so we need to use sine of A over A because we're looking for little a, so that has to be part of the equation. Okay, I need to use either B or C information. Again, B is preferable because 40 degrees is a clean number. Side length B is for a clean number. There are no decimals. Okay, it doesn't have any baggage. Okay, so use those numbers. Okay, so let's go ahead and do sine B over B. Okay, again, if you did use C information, make sure you carry all the digits. Otherwise, your side length A may not be accurate. Okay, all right, let's plug all this information in. Okay, this is going to tell us when I plug in the value of angle A here, I need to use all the digits here. Okay, so the sine of 111.1779614 degrees over side length A has to equal the sine of B, which is 40 degrees, over side length B, which is 4. Okay, so that is what we need to set up to solve this. Okay, so we can go ahead and cross multiply here. Okay, so this is going to tell us that A times the sine of 40 degrees is equal to 4 times the sine of 111.1779614 degrees. Okay, if we want A, we need to divide both sides by the sine of 40 degrees. Okay, and on the left side, these guys will cancel. Okay, this is what we need to pop into the calculator to get side length A. Okay, so let's see here. If we do this, this is going to give us 4 times the sine of, I'm just going to pop up the previous answer, okay, or type in the entire decimal expansion there. I'm going to divide that by the sine of 40 degrees. Okay, and here comes side A. Okay, I'm going to go ahead, I'm at the end of the problem, so I'm just going to go ahead and round to two places after the decimal point. This is going to be 5.80. Okay, all right, so there we go. Here is our remaining component. Okay, we have everything that we need. We've got the measure of all 3 angles, and we've got the measure of all 3 sides. Okay, so that was another instance of the ambiguous case. Okay, this was the situation where we get a single triangle. Okay, so now that you've seen examples 4 and 5, you know the difference between one triangle and 2 triangles, remember what you need to do in the ambiguous case. Okay, so you're going to start the problem, like this is the situation where you know that's either one triangle or 2 triangles. You're going to solve just like normal. You're trying to find the first angle. Okay, so you actually come up with a value for it. Okay, but you need to check if there is a second angle that works, okay? So you need to look at the sine value of that angle, okay, and realize there's going to be an obtuse angle that, or, well, I guess the ones we've done, it's been obtuse, but you're going to see if there's another angle in the first or second quadrant, whichever applies, if it has the same sine value, okay? So basically what you need to do that check, you don't have to draw this out every time. You just need to do 180 minus 180 degrees minus the angle that you found, okay? And that result is the potential second angle, okay? So what you need to do, remember that may not necessarily work, okay? You need to take that potential angle, add it to the given angle in the original information, okay? And if that sum is less than 180, then there will be a second triangle, okay? If the sum is bigger than 180, there's not room for a third angle, so there is no second triangle, okay? So you just need to go over, in particular for law of sines, you really need to focus in on doing one triangle versus two triangles in the SSA situations, okay? And if you need any help, let me know.